Hello, math buddies. Today, we're going to learn about permutation of objects taken or at a time. I am Cherdons and welcome to Math TV. Our targets for number 1, illustrate and define the permutation of an object, and number 2, solve problems involving permutations. Okay, first, let us define permutation. Permutation is the arrangement of objects in which order is important. Permutation of n distinct objects taken r at a time is denoted by small letter n, big letter P, and small letter r. And read as permutation of n objects taken r at a time, where n is the total number of objects and r is the number of selected objects. Our formula: permutation of n objects taken r at a time is equal to n factorial divided by quantity n minus r factorial, where your r is greater than or equal to 0 but less than or equal to n. Okay, if our n is equal to r, then permutation of n objects taken r at a time is equal to n factorial. Remember that. If our n is equal to r. Now let's have an example. N is equal to 5. Our r now is also equal to 5. Why? Because based in our condition, n is equal to r. Now, substituting the value, we have permutation of 5 objects taken 5 at a time is equal to 5 factorial. Simplifying it, we have 5 times 4 times 3 times 2 times 1, it is equal to 120. Okay, let us proceed and evaluate each expressions. We have permutation of 9 objects taken 3 at a time. Our formula: permutation of n objects taken r at a time equals n factorial divided by quantity n minus r factorial. Now, let's plug in the value. Permutation of 9 objects taken 3 at a time equals 9 factorial divided by quantity 9 minus 3 factorial. Let's start with the denominator. 9 minus 3 is 6 times factorial. It is equal to 6 factorial. Then we have 9 factorial here. Expanding it, we have 9 times 8 times 7 times 6 factorial. Why we stop at 6 factorial? Because we can cancel them. 9 times 8 times 7 is equal to 504. And that is our final answer. Next, we have permutation of 7 objects taken 2 at a time. Again, our formula: permutation of n objects taken r at a time is equal to n factorial divided by quantity n minus r factorial. Plug in the value, we have permutation of 7 objects taken 2 at a time is equal to 7 factorial divided by quantity 7 minus 2 is 5 times factorial, it is equal to 5 factorial. Next, we have 7 factorial. Simplifying it, we have 7 times 6 times 5 factorial. Then we can cancel 5 factorial. We have 7 times 6. It will give us 42, and that is our final answer. Example number 2. 7 of the Miss Universe candidates participated in the fun run for a cause. Letter A. In how many ways can the participants be ranked from first to 7th place after the competition? Now, we're going to rank the participants from first to 7th place. It means that we're going to include and rank all the participants. So we have permutation of 7 objects taken 7 at a time. We're going to use the formula: permutation of n objects taken r at a time is equal to n factorial. Substituting, we have 7 factorial. Simplifying it, we have 7 times 6 times 5 times 4 times 3 times 2 times 1. It is equal to 5,040. Therefore, there are 5,040 different ways we can rank the participants from first to 7th place. Letter B. If only top 3 finalists can receive a medal, in how many different ways can the first, second, and third ranks be awarded? Okay, the total number of objects is equal to 7. Then our R is equal to 3. We have permutation of 7 objects taken 3 at a time. Our formula: permutation of n objects taken r at a time is equal to n factorial divided by quantity n minus r factorial. Plug in the value we have 7 factorial over quantity 7 minus 3, that is 4, times factorial we have 4 factorial. Now, 7 factorial is equal to 7 times 6 times 5 times 4 factorial. We can now cancel 4 factorial. So we have 7 times 6 times 5, it is equal to 210. Therefore, there are 210 different ways we can rank the candidates from first to third place. Example number 3. In how many ways can 3 wedding gowns and 5 evening gowns be arranged inside a cabinet if, letter A, there are no restrictions? If there are no restrictions, it means that all the gowns are included. So we have permutation of 8 objects taken 8 at a time. Our formula, permutation of n objects taken r at a time is equal to n factorial. Now, substituting the value, we have 8 factorial. Simplifying it, we have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which will give us 40,320. Therefore, there are 40,320 different ways we can arrange the gowns without restrictions. For letter B, wedding gowns are together. Let us first determine the number of ways to arrange wedding gowns. So we have permutation of 3 objects taken 3 at a time. It is equal to 3 factorial. Expanding it, we have 3 times 2 times 1. It is equal to 6. After that, we need to find now the number of ways to arrange the gowns. So we have 5 plus 1. 5 is the number of evening gowns plus 1, that's for the wedding gowns. Count as 1 because they must be together. So we have 6. Permutation of n objects taken r at a time is equal to n factorial. Plug in the value, we have permutation of 6 objects taken 6 at a time is equal to 6 factorial. Simplifying it, we have 6 times 5 times 4 times 3 times 2 times 1. It is equal to 720. Are we done? No, not yet. Because we need to multiply 6. That's the number of ways we can arrange wedding gowns. Times 720, the number of ways we can arrange the gowns. So we have 4,320 in total. Therefore, there are 4,320 different ways to arrange the gowns inside the cabinet if wedding gowns are together. For letter C, gowns of the same type are together. Again, we need to identify the number of ways we can arrange wedding gowns, and that is permutation of 3 objects taken 3 at a time. It is equal to 3 factorial. Simplifying it, we have 3 times 2 times 1 equals 6. After that, we need to get the number of ways we can arrange evening gowns. There are 5 evening gowns, so we have permutation of 5 objects taken 5 at a time is equal to 5 factorial. Simplifying it, we have 5 times 4 times 3 times 2 times 1, it is equal to 120. We will now multiply the number of ways to arrange wedding gowns times the number of ways to arrange evening gowns. 6 times 120. Then, we will multiply it to 2. Why? Because there are 2 ways we can arrange both gowns. First, wedding gowns and evening gowns, or second, evening gowns and wedding gowns. So, 6 times 120 is equal to 720 times 2, it is equal to 1,440. Therefore, there are 1,440 different ways we can arrange the gowns. I hope you enjoy our discussion for today. See you again for our next lesson. Thank you. Have a nice day and God bless everyone.